What's up, guys? It's super cool teacher Landon here, teaching you guys about margins of error. I'm drinking my super coffee. You guys probably can't see that, but we're going to be talking about margins of error using single means. So this is a real life problem from our math homework. Let's hit record. Up, down. Alright, hopefully that will sync it. So this is a real life college math homework that I have in my stats class. It's a review problem. First day was yesterday, actually. So here's what it says. A local university administers a comprehensive examination to the recipients of a BS degree in business administration. A sample of 10 examinations is selected at random and scored. The scores are shown below. Assume the population is normally distributed. Okay, so let's open up our spreadsheet and copy those scores in, and then we're going to look for the mean and standard deviation. I already did this problem, so here's the answers, but I'm going to show you how we got to those answers. So let's go to our spreadsheet and look for the mean and standard deviation. Here's our spreadsheet, which will be linked down in the description. So our mean, what's the mean? It's the average. So equals average. Put in your parentheses and select the numbers that you want to average. Our average is 77.2. So that's our mean. Our standard deviation is, our formula for standard deviation is STDEV.S because it's a sample. That's what we're dealing with. I believe in the homework it says to round to 4 decimals, so equals round, get in our number 4, comma 4 because we're rounding to 4 decimals, 14.7558, 14.7558. Same numbers, they line up, and 77.2 is already rounded, so don't need to round it anymore. Now determine the margin of error with a 95% confidence. So that means we're dealing with a alpha of 0.05 because it's 95%. The 0.05 gets us to 100. So alpha 0.05. Our n is our number of tests that were selected, which a sample of 10 is our n value, and our t value, so this is where we're looking for our t value. So we're looking on the t distribution, we don't look for the number on the x-axis, so t.n, because we are not looking for the probability underneath the curve, we're looking for the t value, t.n, and this is a two-tailed test, so we're going to put dot 2t, short for two-tail. We have to put equal so it knows that's a formula, 2.t.n.2t, two-tail test, and we're going to put in our alpha and our degrees of freedom, which is n minus 1. 10 minus 1 is 9. So here is our t value. If you don't know why we're doing this, the formula to find the margin of error, here's our formula right here. So we are finding the t value, and then we're going to multiply it by standard deviations over n squared, which is this box right here. Standard deviations is equal to this number over the square root of 10, because that's our n. So then we get that. Our margin of error is when we multiply these together. There is our margin of error. So it says round to 3 decimals, and we get 10.556. Let's round this to 3 decimals, 10.556. So then our margin of error is plus or minus that margin of error. Our mean plus or minus the margin of error. So our high is going to be our mean plus the margin of error. And then our low is going to be equals to the mean minus the margin of error. And it says to round to 3 decimals, which it did, 8.7.756 and 10.644, which is correct. So that's how you do margin of error using one sample mean. Thanks for watching. If you liked today's video or it helped you, all I ask is that you share it with a friend. And with that being said, I'll see you guys in the next video. Peace.